Okay, so let's look at question number 2, chapter 18 in class activity. It is an isobaric expansion problem. So it says, with the pressure held constant at 210 kilopascal. So pressure, so this is chapter 18 in class. So pressure equals 210 kilopascal constant and 49, so mole 49 moles, those are the given, expands from the initial volume. So Vi is given as 0.75 the cube, and V final is given as 1.9 meter cube. So draw the PV diagram. So let me divide this into two, and these are the given, and so a PV diagram. So pressure versus volume, meter cube, kilopascal. So 0.75 to 1.9. So pressure constant, it's an expansion, the arrow goes from left to right, and I would say here 210 kilopascal. And then how much work was done by the gas during the expansion? So when pressure constant, the work done can be written as P delta V. So 210 times 10 to the 3 Pascal times V final minus V initial, which will give you 210 times 10 3 times 1.9 minus 0.75 meter cube. So work done in joule. If you simplify this, you get 241,500 joules. That's work done. Okay, so see what were the initial and final temperatures of the gas. So if you look at the PV diagram, if you look at the initial state, you know Pi equals 210 kilopascal, Vi equals 0.75 meter cube. So if you use PV equals nRT, you can find the initial temperature, which is Pi over Vi over nR. Okay, Pi is 210 times 10 3 Pascal times Vi 0.75 divided by 49 moles times 8.31 joules per Kelvin per mole, right? So then Ti is going to be 386.8 Kelvin. Similarly, you can find Tf, which is given by the same pressure 10 3, the volume now 1.9 meter cube, and 49 times 8.31 joules per Kelvin per mole. If you simplify this, you will have 979.88 Kelvin. So these are the two temperatures that we are interested in. Okay. Now the last part, what was the change in the internal energy of the gas? I'll try to do it this little space here. CD. Now we know that the internal energy is given by U equals 3 over 2 nRT. If you want to find delta U, change in internal energy, since it is a state function, we can do delta t. Okay, so delta u equals 3 over 2 n, which is 49 moles. R is 8.31 joules per Kelvin, joules per Kelvin per mole, times delta T, 979.88 minus 386.8 Kelvin. So if you simplify that expression, your delta T is going to be 362244.36 joule. So now work done is this much, internal energy change is this much, and temperature changes are this much. So now the last part is how much heat was added to the gas. Okay, so let me, as part E, how much heat was added to the gas. So first law of thermodynamics, delta U equals Q minus W. So Q is going to be delta U plus W is work energy. So we found how much internal energy change, which is 36, 22, 44.36 joules. How much work done, which is positive 241,500 joule. So internal energy change is positive, work done is positive, so heat is positive, which tells us that this much of heat flow into the system to do work as well as to increase the internal energy. So 744.36 joule. So isobaric processes, in isobaric processes, heat flow in to do work and increase internal energy. Okay. Okay.